Hello students, welcome to ACE Engineering Academy Preparation League Season 2 and myself Ramesh Masuna. I'm welcoming all of you on behalf of ACE Online powered by ACE Engineering Academy. Today I'm going to take the important concepts in database management systems. Yesterday, we have discussed the preparation strategy for database management system. Now we are going to continue with some of the important concepts in DBMS. Yesterday, I have started my session with weightage analysis, and these are the various topics in DBMS, ER models, relational models, functional dependency, normalization, algebra, calculus, SQL, transactions and concurrency, recovery system, indexing. And I have shown you yesterday from which topics questions were asked in the previous GATE and on what topics there is a possibility of asking questions. Now in this session we are going to discuss some of the important concepts and the questions related to the GATE standards. Yeah. Here we know that these are the weightage analysis, and yesterday we have discussed the SQL is very, very important. Undoubtedly, SQL is very, very important because more weightage is there on SQL, and then next on algebra and calculus, dependencies and normalization. These are almost equal weightage, means almost every year you are getting minimum one question from these topics, and there are other topics also, and from there you are getting some questions. When you see the past 5 years of papers, especially I'm talking about past 5 years of papers, every year you are getting 5 questions. Every year getting 5 questions. It is standard, I am telling you, only 5 questions are getting. But that 5 questions, sometimes only 1 mark questions and 4 2 marks questions, totally 9 marks asked. Sometimes 2 1 mark questions, 3 2 marks questions. So it will be 8 marks from DBMS. Sometimes 3 1 marks questions, 2 2 marks questions, totally 7 marks. Right? So this is 9, 8, 7. On average, every year you are getting 8 marks from the DBMS, on average, most of the times. But that 8 marks are from these 5 questions, and these 5 questions are from these 7 topics. In that 7 topics, recovery system I am not considering. Why? Because so far it is asked only 3 questions. If I am ignoring that recovery system, how many topics are there? 6 topics. In that 6 topics, how many questions? 5 questions. And one important thing is that 5 questions are from 5 different topics. From no topic 2 questions are asked. From each topic 1 question. 5 questions from 5 different topics. Now you only tell me which is important topic. All are important. So most of the times many students are asking to me after the class, if I take after the class, after my class, some of the students are coming to me and asking me, sir, what are the important topics? Then just I will give a smile to them and tell to them that DBMS is important. Yes, my dear, DBMS is important. I cannot say it is this topic is important, that topic is important, because totally 6 topics are there. In that 6 topics, 5 questions from 5 different topics. How can I tell you that which topic is important? Every topic is important. That's why I'm telling you DBMS is important. From DBMS, on average, you are getting 8 marks. 8 marks is not less. 8 marks is more. More marks you are getting right now. So that's why I'm saying you DBMS is important. And DBMS is, when compared with some of the other subjects, DBMS definitely it is very, very easy subject, undoubtedly. Chalo, today we are going to discuss about some of the important concepts in DBMS. I will discuss that important concepts through questions. It is called concept through questions. Yeah. Very first, I would like to give this question. And look at this question. I recommend you read this question and try to understand and answer. Because yesterday I was telling that the question could not be direct questions. Questions should be something slightly different questions, you can expect it. So this is a different way of asking questions. Please think and answer it. Just let me check the top chat. So any students are answering the question? If any students are answering the question, I will be happy. So you are, because here is a live chat is there, you can use that live chat and give your answers. Any answers?
Hello everyone, my name is Karthik.
Any answers? Okay, so what? No answers. Maybe people are reading it. Okay, I'll wait for you to give the answer. Here, what is given? Consider the binary relationship. So V logs. Some student given answer option D, sir. Okay, option D. Happy? So name is V logs. Okay, some name he used. V logs. He gave the answer is option D. Okay, any other people who are in the live session? Chalo, let me check the question. One student given answer is option D, but option D is right or wrong. We'll check it out. Look at the question. Consider the binary relationship type between biological mother between entity types person and woman. So person is one entity set, and woman is another entity set, and woman is a biological mother for a person. Woman is a biological mother for a person. Suppose the cardinality ratio person to woman constraint. Person to woman constraint. Of the relationship is expressed using minimum maximum notation as UV on the line connecting person and biological mother. Between person and biological mother, U comma V is there. Okay, this is UV is called representing that cardinality in the form of minimum and maximum. Means one person can be a biological mother, one person is connected to how many humans as a biological mother, or minimum and maximum. That is our question. And notation as UV on the line connecting person to biological mother, and XY on the line connecting between woman and biological mother, XY. Means one woman is a biological mother to how many persons? Minimum and maximum. A person is to have a biological mother, how many women as a biological mother, minimum and maximum. That we have to represent it. Now we have to understand the real world scenario. Which one of the following is correct? And you may be thinking about what is a biological mother? Biological mother means, because you know it, surrogacy is there. So that it is, surrogacy means the woman who carries a baby in her stomach, the baby is of some others, not the same woman's, right? Now, that's why we use the word biological mother. Look at one person can have how many women as biological mother? One person can have how many women as biological mother? One person, minimum one woman as biological mother. And one person can have one woman as a biological mother, minimum and maximum. Why? Because for one person, only one mother is possible. For one person, 0 women as biological mother not possible, because a person never be existed without a mother. Right now. So means there is a 1-to-1 relationship possible. Means person to biological mother is 1-to-1. And look at, when I'm talking about woman is a biological mother to how many persons? And woman is a biological mother to 0 persons possible. Means that woman not giving birth to any persons. If that woman not giving birth to any persons, the woman is not the biological mother to 0 persons. And because an woman can be a biological mother to many persons also possible. Many persons. Why? Because one woman can give birth to many persons. So that N, because maximum representation means person to biological mother is 1-to-1 and woman to biological mother is 0, 1. So that what should be the answer? 1, 1, 1 N. This 1 N says that one woman can be a biological mother to at least one person, but it is not compulsory that a woman should give a birth to a person. It is up to that woman. That's why you can say option A is wrong. And here you see person to biological mother 1 in given. Means one person can have many biological mothers, but one person can have only one biological mother. Why? Because one person can have only one mother but not many mothers. So that this is incorrect. And one person can be a biological mother to minimum one woman and maximum one woman. And one woman can be a biological mother to 0 persons or many persons. So that answer is option C and option D is incorrect. Hope vlogos, some name is given here, vlogs. Vlogs, I hope you understood the answer. That is an option C. And friends, I hope most of you have understood this question. Okay, right. Kiran Pogul, hi Kiran Pogul. And vlogs, it's C, right? I think vlogs now you understood, it is a C. And good evening, sir. Good evening, GATE Easy CSE. Good evening, right? Okay, have a look. Next question, have a look. Consider the following table with 2 attributes A and B, where A is primary key and B is foreign key, referencing A. A is primary key and B is foreign key, referencing A. This is one more question. A is primary key, B is foreign key, referencing A. It is given. And some table is given, table along with the data. Now question is, which of the following statements is or false? Which of the following statements is or false? So yesterday we were discussing about in ER and relational models, some theoretical questions are possible. That is a previous question. And next on relational model, questions were asked on foreign keys. On foreign keys you can expect a question. Here this is a kind of a question. Which of the following statements is or false? Which of the following statements is or false? These are the statements given. One thing we do, just give me a minute so that I can do something for you. Here I copy, just I will put options at this place so that it will be easy for you to read these options. Yeah. Have a look. Right. Now look at this. And these are the options are given. And okay, let me make it a full screen. And these are the options are given. And this is a table of data. And now question is which of the following statements is or true? Which of the following statements is or true? Here how many statements we have? 1, 2, 3, 4 statements are given on the table of data. Now question is which statements are true? Will you try? So I'll be standing here so that you can see the table and you can see the options, statements, and try to give the answer. At least you can give the answers part by part, like statement 1 true sir, statement 2 true, statement 3 true, likewise, true, false, like statement 1 true, 2 true, 3 true, likewise, true, false you give it, so that I can understand. So how many statements are true, how many statements are false? Right, at least you can give answer, like statement 1 true sir, statement 2 true. Okay, if you try, it will be happy. Okay, anybody is going to give the answer? Okay, maybe people are thinking on it. So that's what I am telling you. It is important to understand the concepts so that if any question comes, you should be in a position to answer it. Okay, I think people need some more time. Yeah, Vijay, 1 and 3 false, Vijay. Okay, Vijay, Vijay given a response 1 and 3 are false. 1 false, Vijay. Okay, 1 and 3 false. Okay. Chalo, we'll look at is 1 and 3 are false or not. Okay, Vijay is responded. So all of you, those who are watching, you also try for these options. Look at the first option. If B is the foreign key referencing A with on delete cascade, then on deletion of a tuple 1 comma 4, 3 more tuples will get deleted. Is it true or false? We'll check it out. On deletion of a tuple 1 comma 4, 3 more tuples are deleted. On deletion of 1 comma 4. Okay, I'm deleting 1 comma 4. If 1 comma 4 is deleted, 1 is deleted from the primary key. Look at 1 is under primary key column, 4 is under foreign key column. So means whenever you perform any deletion on the parent, it requires to check, is it having any related records in the child table. Look at 1 is related to here. So means for 1 we have a related record. What is that related record? 3, 1. 3 comma 1 is the related record. Right now. Now what is the condition it said? On delete cascade means on foreign key if you have on delete cascade, it means whenever you delete a tuple in the parent, it requires to delete its child tuple. Means 3, 1 is also be deleted. And deletion of 3, 1 causing deletion of 3 from the parent. Whenever you delete 3 from the parent, it requires to check its child record. Now 3 in the foreign key column. 3 in the foreign key column is there in 6.3. So means it requires to delete 6.3. And whenever you delete 6.3, it is mean that you are deleting 6 from the parent. They have to look in the child. 6 is a child for 7, 6 tuple. So means it requires to delete 7 comma 6. Whenever you delete 7 comma 6, 7 you are deleting. And look at 7 in the child. Do we have 7 in the child? No. So means when deletion of 1, 4 causing deletion of 3, 1, and deletion of 3, 1 again causes deletion of 6, 3, deletion of 6, 3 causes deletion of 7, 6. So what is the statement given? If B is the foreign key referencing A with on delete cascade, then on deletion of tuple 1 comma 4, 3 more tuples will get deleted. See, when 1, 4 deleted, what are the tuples that are deleted? 1, 2, 3 more tuples. So statement 1 is true or false? What, Vijay? Statement 1 is true. Right now, statement 1 is true. Right, it is a true statement. Because question is about false, first statement is true. Right now. Okay, Vijay, 1, 3 false given, 1 is true, Vijay. And fine, Srividya, question is about false. And statement 4 is false, sir. Okay, nice, Srividya. Right, okay, any more? GATE, easy, CSE, okay, got some message. Fine, the first statement is a true statement because question is about false. Now look at question number, statement statement 2, second statement, have a look at. This is a true statement, okay, second statement. If B is a foreign key referencing A with on delete set null, then no more tuples will be deleted if any particular tuple is deleted. Means whenever you have a condition on delete, set null is there, on delete set null. What is the meaning? Whenever you delete some tuple from the parent, it requires to check its related record. Its related record is assuming 3 comma 1. Its related record is 3 comma 1. When 1, 4 is deleted, it requires to check its related record. Previously, we have on delete cascade so that this is also to be deleted. But if it is on delete set null, simply foreign key value is to be set with null. Any more tuples to be deleted? No more tuples to be deleted. So that second statement is also true. Because first statement is true, question is about false. So actually this is option A. Okay, option A is 1 comma 4. Fine. Because question is about true. So option B is wrong, option D is wrong. And because 2 is also true, question is about false, 2 is true, so that option C is wrong. And option A, actually it is 1 comma 4. 1 is true, 2 is true. Look at option, statement 3, On deletion of a tuple 9 comma 8 and using cascade delete option, tuple 5 comma 9 will also get deleted. On deletion of a tuple 9 comma 8, look at, when you delete 9 comma 8, 9 is deleting from the parent, it requires to check its child tuple. What is the child tuple? 5 comma 9, and that is also to be deleted. This is also true statement. Okay, 1, 2, 3 are true statements, and fourth statement you look at. By using on delete cascade option, on the maximum number of tuples get deleted on deletion of tuple 7 comma 6. If you delete 7 comma 6, any more tuples to be deleted? Look at, any more tuples to be deleted? 7, if you delete it, 7 is not in the child. So when you delete 7, 6, no more tuples to be deleted. But it said maximum number of tuples are deleted. This is a false statement. And previously we have seen when 1 comma 4 is deleted, it is causing deletion of 3 more tuples. But when deletion of 7, 6, it doesn't require any more tuples. That's why fourth statement is false. Actually option 4 is misprinted. It is only fourth statement is false, remaining are true. So answer is option A. A is the right answer. So yesterday I was telling that in ER and relational models, theoretical questions possible and questions on foreign key. I had one more thing I told you, the questions possible on the conversions. Okay, I will show you one question on conversion. This is one ER model, simple question only. If you feel it is simple only. It is an ER model, and question is, what is the minimum number of relations required for building the relational model of the above ER model? So when you convert that ER model into relational model, how many tables are possible? This is a model, and you tell me how many tables are possible. Tell me any answers. Vijay, any doubt? After 7 comma 6, sir. Okay, fine. I think Vijay, you got na? Done. Can anyone tell me what is the answer for this question? What is the minimum number of tables is a question? Because I told you yesterday, in ER and relational models, 3 possibilities, some theoretical questions, and questions on foreign key and questions on conversions. So one question on theoretical we have discussed, and one question on foreign key, now one question on conversions. Any answers? I can see your top chat. You can put your answers in the chat box so that I can answer you. Any answers? Okay, I'm waiting. Okay, GATE Z, Kiran, Pogal, Vijay, Srividya, answer. No. Are you feeling a difficulty in this question? Expected quick answer from you. I think maybe you are confusing with some notation. Correct? Are you confusing with some notation? Okay, it might be, but no answers are getting. Okay, let me check. Maybe you are confusing with notation. So look at this one. Suppose entity A relationship R and entity B. Suppose if I wanted to show A is a key to the relationship, we call key constraint. Previously, we write key constraint from entity to the relationship, entity to relationship. Now I can change this as this way: A relationship with B, A relationship with B. It says that A is key to R means A is a key to R to determine B uniquely. There is a meaning of it. Because A is determining B uniquely through R, so it is also is a same notation, means you can have an arrow from A to B or A to R, both are same. Now here you look at, I think you might have a problem with this notation, and maybe you found the problem with this notation. M to R2, like this is E3 is a key to E2, and because arrow you can see, you have seen this direction, means according to general notation, we can say this is a key, means NDD2 relationship, and showing that A to R is same as A to B, okay, that point you keep in mind. E3 to R2 is same as E3 to E2, because in the question it is given E3 to E2, it is same as E3 to R2. Suppose you might have practiced E3 to R2, and in the question it is given E3 to E2, don't get confused. If required, you can convert according to your notation. Suppose you practice E3 to R2 and it requires that one, you can opposite way, you can convert it if required, whichever the notation it is comfortable. And you know that in order to find the minimum number of tables, it requires to merge relationship with entity sets. Look which relationships are possible to be merged, like because it is M to N relationship, no key constraints are possible. Because it is M to 1 key constraint is from M side. So that this relationship you can merge with E3, this is one table. And any more mergings possible? No more mergings. Here assuming A and C, and here A is a key, and no more mergings means E2 separately one table, R1 separately one table, E1 separately one table. So how many tables? 1 and 2 and 3, and this entire thing is 1, and this is 4. So the minimum number of tables are 4. Okay. Anybody give an answer? Let me check. Okay, no answers. Okay, Tej Prabha. Tej Prabha, I think 3 sir, but not 3 Tej Prabha. You look at Tej Prabha, 1 and 2, 3. Okay, sorry, here R3 is there. This is also 1. It is a fifth relation, sorry. Because R3 you have to make it as separate table, right? This is 1, 2, 3, and this entire thing is 4, and R3 is 5. So totally 5 tables. Okay, right. Okay, Tej Prabha, it is 5 tables, not 3 tables. Done. Chalo. We'll go for one more. So it is answer is 5 tables. Now next, in the next chapter, that we have discussed functional dependencies and normalization. In functional dependencies and normalization, the possible questions are on dependency verifications, one possibility, functional dependency verifications. And there are other possibilities are additional dependencies. And next, we have minimal sets of dependencies and finding the keys of a relations, and questions on decomposition properties, and questions on normal forms. So what are the topics? Dependency verifications, additional dependencies, equivalence of not equivalence on question not asked, functional dependencies, additional dependencies, minimal sets, and finding the keys, properties of decomposition, and normal forms. 6 topics I told you. From these 6 topics, questions were asked. Like here we will discuss some of them. Here is a question: consider the relation R of A, B, C, D, E, F, G, and following functional dependencies are given. Which of the following statements is are true? Question is about which of the following statements is are true. Srividya Naundla 5, Vijay Srividya laughing, okay. Badma Priya 5 sir, okay, that is over now. Okay, that question is over. Tej Prabha, okay sir, okay Tej Prabha, thank you. Right. So what is the answer for this question? I think it is very simple question for you. Just I have included this question because questions are possible on this topic also. Answer. What is the answer for this? Hello. I'm not getting any answers. Okay. Satyam C. Okay, Satyam C. Done. Satyam given an answer C. What about Badma Priya, Tej Prabha, Srividya, Kiran, Vijay? So many are there. I am calling you. Hello, I am calling you. Tell me answer. Srividya D. Okay, Srividya D. GATE CSE B. Oh. So is it that much tough? Because people are selecting almost all options. Some students selected C, D, B. Okay, what about others? Okay, Vijay selected A, right. Nice, Vijay. So I thought nobody is there to select A, B, C, D, C. Now Satyam given C, Srividya D, and GATE CSE B, and Vijay A. Okay, different answers. Nice. Okay. Okay. We'll check it out. Which option is correct? What was the question actually? There are some dependencies are given. Which of the following statements are true? So how to verify which statements is true? Simple. There are dependencies are given. When x to y dependency is given, when I can call x to y dependency is possible, if you take the closure of x and if that closure of x contains y, then x to y is possible, right? Now, then x to y is possible. Now AC to F is possible or not? Take AC closure. What is AC closure? AC. With A we have E, right? Now, any more possible? No. Question is about true na. So means AC to F is not possible. AC to F, not possible. Vijay selected AC to F. And Badma Priya D, Tej Prabha D, Srividya Naundla B. Again Srividya, again you are changing. D to B. Okay, are you changing B? So simple question. Right, okay, let me check. ABC to EF possible or not? ABC closure, that is ABC. And with A we have E. With BC we have G and D. With D we have F. Means with ABC, E possible and F possible. So what is the option B given? ABC to EF. So B is the correct answer because true na. Because true, B is the right answer. Srividya true, GATE CSE B. Okay. So other options could be wrong. Now look at ABD closure. What is ABD closure? ABD. And with A we have E, with D we have F but not C. So option C is wrong. So that what is the correct answer? B. B is the right answer. Okay. And do remember, so here I can tell you some examples. Srividya first selected D, later selected B, and so you don't have a second option. Whatever you have selected, that is a final, right? Okay. So be careful. Sometimes what happens now, you feel it is simple, but with whenever you feel simple, you may do some mistakes. I thought every student will give the right answer, but see, this is happening, right? Okay. Now next question. Next possibilities on dependency verification, additional dependency, and minimal sets. So far only one question asked, and important thing is candidate keys. How many candidate keys questions? That is important. Now here is a question. The number of candidate keys for R is how many candidate keys? Can anyone tell me? Quickly. I wanted very quick answers. Vijay cleared. Okay, Vijay. Any answers? So I'll give you 1 minute. Try for it. Oh, very good. Is it? What is the answers? The number of candidate keys for R is, the question is number of candidate keys for R is, how many candidate keys for R? Any answers? Hello. Okay. Srividya 3, AFD, Vijay 4, Vijay 4. Okay, Srividya 3. Srividya 3, what are the three? A, F and D. Is it A is a key? Okay. Look, how do you find the key? When you look AB closure, what you are getting? A, B, D, E. With D we have E, F, A, B, D, E, F. A, B, D, E, F, but not G, but not C. And look at what are the dependents? D, E dependent, E, F dependent, A dependent and B independent, correct now? Look at B independent, C independent, because C is not in the right hand side, B not in the right hand side, G not in the right hand side. So means B, C, G are the independent attributes. As you know that B, C, G are the independent attributes, and independent attributes are compulsory to be part of a key. Okay, before that we have A to B, C, sorry, I didn't check it. So when you take the closure of A, B, C, with AB we have a DE, okay, sorry, AB we have a DE, okay, BC are dependents now, this is not independents, and G is dependent, I think, right? G is dependent, because BC is, G is independent. What is there in the right hand side? A, and here BC, and here we have DE and EF. So only G is independent. When you find the A closure, A, B, C, D, E, with D, E, F, G is not there, so that G is independent, independent is compulsory. So when I can take AG closure, I can get A, G, B, C, D, E, F. So I can say candidate key is AG. Now replace attribute, prime attribute A, which is there in the right hand side of F2A, with F. So FG is also a candidate key, and we have a D to EF, F is in the right hand side of D to EF, F you replace with D, and DG is also this one, candidate key, and D is there in the right hand side of AB to DE, because D in the right hand side of AB to DE, D can be replaced with AB, so we can say ABG. But you observe, when AG is already candidate key, ABG is called super key, but not candidate key, it is super key. So how many candidate keys possible? AG, FG, DG, so 3 candidate key possible. So the number of candidate keys are given. Question is number of candidate keys 3, and it is 3. Srividya 3, okay, AG, FG, DG, good. But again, Srividya, you did previously you gave AFD something, but it is not AFD, it is AG, FG, DG. And Vijay and Padma Priya, you both given 4. Vijay has deleted his message of 4. Okay, Padma Priya 4. Is it clear, Padma Priya and Vijay? So the number of candidate keys are not 4, it is 3. Okay, it is not 4, 3. Is it okay, Padma Priya and Vijay? Right, I think it is clear for them. So I will show you. And questions are possible on the decomposition properties and normal forms also. Here I'll give you one simple question. Okay, one question I'll give you here, which is based on the normal forms. Consider the following relation schemas: teacher, allocation. 2 tables are given. Following are the functional dependencies. Dependencies are given. And the question is, which of the following option is true for the relation given above? It is asked previously, you have questions where one relation is given and ask it what normal form of the relation. Now, instead of one relation, you can expect a question like this, like 2 relations, and which relation is in which normal form. Look at what is the answer for this? Okay, Padma Priya, now I got it, sir. Thank you, Padma Priya. Which I thought super keys is also candidate keys. Okay. Candidate key is a super key, Vijay, but every super key need not be a candidate key. Srividya, I didn't see G, sir. If I didn't see G, it's not a problem. You have to see everything, right? Because you are going to write the GATE examination. Srividya? Right. Okay, done. Fine. See, look at what normal form. Like question is, which of the following option is true for the relations given? Which of the following options is true for the relation given? So any answers from your side now? Consider the following relation schemas. A teacher ID to designation is one dependency, and designation to salary is one dependency. So that teacher ID is going to be a key for the relation. And when teacher ID is a key, designation to salary is a transfer dependency, so it is in 2NF, not in 3NF. And look at allocation. In allocation, we have a teacher ID to salary, it is there, designation to salary, okay. Teacher ID to, look at teacher ID to designation is shown, designation to salary is shown on the first table. Teacher ID to salary, that is not there because teacher ID to salary, okay, this is also a dependency, but designation to salary is a transfer dependency. And this teacher ID subject to classroom is there in the allocation table. And what is the key for this teacher ID and subject together? Because teacher ID subject together is a key, then teacher ID subject to classroom, it is in BCNF because no other dependencies are there in this. Because it is BCNF means it is also 3NF, 2NF and 1NF. And this is 2NF also in 1NF. Now question is, which of the following options is true for the following given relation? Teacher is in 2NF, okay, correct. And allocation is in 1NF, correct. But normal form says the highest normal form condition. Okay, this statement is correct, but question we will check it out. Which, if any other option having higher normal form, that we have to select. Teacher is in 2NF, correct. Allocation is in 3NF, this is correct. Means always it requires to select the highest normal form. But here not BCNF is given, so when I compare with option A and B, I can say B, I can go for B because normal form says the highest normal form condition satisfied by a relation. So A incorrect and I can say B correct, and if there is some other options where it is given allocation is in BCNF, then I can ignore this option, that option I have to select. And it is given teacher is in 1NF, when teacher is already in 2NF, then teacher is in 1NF correct only, but always we have to select the highest normal form condition. So that option C is incorrect. And option D, teacher is in 3NF given. Here it is 3NF, but teacher is in 2NF. So that option D is incorrect. Answer is correct answer option C. Sorry, option B is the correct answer. Okay, done. Badma Priya got it. Okay, fine. Srividya, B. Nice. I hope you understood this one. And here, algebra is very, very important. As I told you in the yesterday's session also, algebra is important because majority questions asked from the algebra. Here question could be slightly different. Here look at, given two relations, relation P and relation Q, two relations have given. And if tuples returned by query 1 is X and tuples returned by query 2 is Y, and what is X plus Y is the question. What is X plus Y is the question. Okay, if possible, try to note down that query 1 and query 2. And I will show you the slides of tables of data of P and Q. Just copy these questions in some rough paper. I'll show you these questions. I'll show you the data. Then you can solve this and try to answer. Try to answer it. I hope you have taken. And first query is joining both P and Q with respect to, and it is a natural join of P and Q and projecting AC columns. And second query is projecting AC columns from PQ relations where join condition is PB equal to QB. This is SQL query, that is an algebra. And SQL query output is X tuples and algebra query output is X tuples and SQL query output is Y tuples. And now question is what is X plus Y? You can expect different way of asking, that's it. There is no new questions because it is diluted topic, but way of asking may be different. Now I am showing you data. Now join, natural join between P and Q. How do you perform a natural join? B equal to B condition. Look at how many mappings are possible. And what is to project? A and C. The first query output is X tuples projecting A comma C. And what tuples are possible, you can check it out. This is 1 equal to 1. This is 1 equal to 1. And 2 equal to 2. 2 equal to 3, not there. For 4 we have a matching. And 5 we have a matching. 5 we have a matching. Okay, these are the mappings are possible. And for 1 we have a match. So X, A comma C. For this one we have a match with this one. And AC is 1 comma 2. right? And this 1 had a match with this 1, 1, 1 matching, that is 2 comma 2. For this 2, we have this matching, and this is A and C is 2 comma 2 because algebra eliminate the duplicates. So 2 comma 2 already there, it will not show one more time. This is one tuple, this is another tuple. And this 4 is matching with this 4, and AC is 3 and 3, 3 comma 3. And this 5 is matching with this 5, and A comma C is 3 comma 3, okay, that is already there. So how many tuples here? The algebra query, 3 tuples. So because it is eliminating the duplicates. And what is a SQL query? Any answers? Okay, Srividya 10, okay, Vijay B, okay, fine. What is SQL query? Select A comma C from P comma Q where PB equal to QB. So it is general query, simple SQL query. It is also selecting A comma C with the condition PB equal to QB. A comma C, PB equal to QB. So what are the mappings now? B equal to B now, 1 equal to 1 true. So 1 comma 2 possible. This is one tuple. And 1 equal to 1 here is matching. Only one mapping is there. So that 2 comma 2 possible. And this 2 equal to 2, this is matching. And this 2 and this 2. 2 comma 2, one more 2 is possible. In SQL, it won't eliminate the duplicates. And this 4 is matching with this 4. Here A is 3 and here C is 3, 3 comma 3 possible. And here look at, this is a 5 and it is 5. And this is a 3A, this is a C3 and 3 comma 3 is possible. So how many tuples possible? 1, 2, 3, 4, 5. And here 5 tuples in Y and 3 comma 3, like 3 tuples in X. Now what is X plus Y? Now what is X plus Y? Here it is 3 plus 5, that is 8 tuples. That is 8 tuples. 8 tuples are possible, right? So answer is, what is X plus Y? What is X plus Y? X plus Y is 8 tuples. This is a possible question on the topic. Right, fine, this is 8 tuples. Fine. Okay, Vijay 5 given. Vijay 5 is incorrect, and Srividya 10 again changed Srividya. It is 8. Okay, 5 plus 3, 8. Okay, very good, Vijay. Now you corrected. Okay, 5 and 8. Badma Priya, good, 8 tuples. Okay, and because it is a 1 hour session to discuss some of the important concepts, so here I tried my level best to give some of the good concepts, and yesterday I have given what are the topics important in the overall subjects, and now few questions which is possible that we have discussed. And if you have some more sessions in the future, we'll have definitely. And I'm going to give you some of the good questions so that you can practice all of them and get some benefit out of it. I hope you have enjoyed the sessions. And with this, I would like to conclude the session. Thank you. Good day. Good night.
Thank you. My name is Gaurav. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong basic required for the exam. My metrics for the future aspirants were preparing for GATE exam. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy, and if you will work hard, you will definitely achieve your goal. Thank you. My name is Gaurav. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy, and if you will work hard, you will definitely achieve your goal. Thank you. My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and